So welcome back again. Today in this video I'm going to explain about cluster configurations. In previous video we got to know about the types of clusters, and when we create a cluster we will be presented with the number of configuration options as you can see here, and in this lesson I will take you through each one of these in detail. So at first we have the options to choose whether we want to create a single node cluster or multi-node cluster, as you can see. So multi-node cluster will have one or more worker nodes or the executive nodes, as we discussed in the previous video. So when you run a Spark job against a multi-node cluster, the driver node will distribute the tasks to run on the worker nodes in parallel and returns the results to that, and they gives us the ability to horizontally scale the cluster depending on your workload. So when so in that case we can basically keep adding worker nodes as we need, as much as we need. So these are the default type of clusters used for Spark jobs and suitable for large workloads in multi-node. And where coming to the single node, on the other hand, this will have only one node, which is the driver node, and there are no other worker nodes like a multi-node cluster. So even though there are no worker nodes, single node cluster also supports Spark workloads. So when you run a Spark job, the driver node acts as both the driver and workers, as there are no worker nodes. So the single node clusters are not horizontally scaled like multi-node cluster. It is not horizontally scalable, and so they are not suitable for large ETL processing, for large extract and transfer and load. For these type of operation and these type of workloads, it will not support multi-node, and they are mainly targeted for lightweight machine learning and data analysis workloads which don't require any distributed computing capacity. Then we need to specify the or define the access mode. There are four different types of access modes available at the moment for the cluster. So as the name suggests, single user. So this is, as the name suggests, single user access mode only allows the single user to access the cluster. So it supports all four languages like Python, SQL, and Scala, and these are the R programming, and these are the different types of access modes available. And coming to the shared access mode, it allows the cluster to be shared amongst more than one user, but it provides process isolation. So each process gets its environment, so one process can't see the data or the credentials used by the other one. And where coming to and it's only available on premium workspace. Also it only supports Python, Scala, these type of workloads. And third one is no isolation. So no isolation shared also allows the cluster to be shared amongst more than one user. It available on both standard and premium workspaces. Also it supports all four languages. One is Python, Scala, as you can see here, SQL and R programming. So the main difference between these and the shared access mode is that no isolation share access mode doesn't provide any process isolation. So failure in one user process may affects the other also, and they don't offer any task permissions or preemptions, and so one running process may use all the resources and the other may fail. And most importantly, as everything is shared, it's considered less secure, where coming to the custom access mode is not an option. And when you create the cluster using the latest user interface, you are only likely to see this if you have already created cluster using the legacy configurations. The third most engaged, a Databricks runtime. And Databricks runtime are the set of code libraries that run on Databricks cluster. And here Databricks runtime offers four types of runtimes. Here you can see data one is Databricks runtime ML, and Photon runtime, and Databricks runtime. So Databricks runtime Lite. So let's go each one of them. The first one is Databricks runtime includes an optimized version of Apache Spark, this Spark library, and Java, Scala, Python, and these are the libraries, and Ubuntu, and it's accompanying the system libraries, also GPU libraries for Databricks services, and that integrates with other components of platforms such as this notebooks, jobs, and cluster manager. And Databricks runtime ML includes all the libraries from the Databricks runtime, plus popular machine learning libraries such as PyTorch. So this means this Databricks runtime includes all Databricks runtime and and including ML libraries also such as PyTorch, Keras, TensorFlow, and etc. So Photon runtime is also includes all the libraries from Databricks runtime plus Photon engine, including this Photon engine, which is the Databricks native vectorized query engine that runs SQL workloads faster and it will also reduces your cost per each workloads. So Databricks runtime Lite, this is a runtime option for only jobs requiring advanced features such as auto scaling and reliability and improved performances, and also it only suitable for automated workloads. You can't use it for interactive workloads or notebook jobs. So the fourth one is auto terminations. Auto termination is a nice feature that will avoid unnecessary costs on idle clusters. That means it's especially useful on Hadoop clusters and for preventing them running during the evenings and weekends when they are not in use. So you can specify when to terminate your Databricks cluster if the cluster has not been in use. So it will be terminated after the number of minutes that you are going to specify. And default value for the automation is 120 minutes, and but you can't change the value after once you specify, and the accepted value ranges from 10 to 1000 minutes. So when you create a multi-node cluster, you can specify the minimum and the maximum number of worker nodes. Autoscaling will automatically add or remove nodes from the cluster depending on your workloads, and this can result in optimum utilization of the cluster. So it will specifies the minimum, it requires minimum and the maximum number of worker nodes, and it also auto scales between minimum and the maximum based on the workloads that you are giving, and it is also not recommended for streaming of large amount of workloads. There are wide variety of wide array of Azure VM types available for us to use, and Databricks groups them into small number of easy to understand groups. This memory optimized instance types are recommended for memory intensive applications. For example, a machine learning workloads that catches a lot of data in a memory. And the second one is compute optimized, and this compute optimized instance types can be useful for structured streaming applications where you need to make sure that the processing rate is above the input rate at peak times of the day. And these can also be used for distributed analytics and data science applications. And the third thing is storage optimized. The storage optimized instance types are recommended for use cases you requiring high disk throughput and input output. This general purpose instance types are recommended for enterprise grade applications and analytics within memory caching. And this the last one is the this is the GPU accelerated. This instance types are recommended for deep learning models that are data compute which are intensive. So final one is cluster policy. When, as we have seen, there are lot of options when you are configuring from the cluster, and this cloud is easily overlay a data engineer or a machine learning engineer, and creating clusters becoming the role responsibility of the admin, because it's too difficult to configure for a standard data engineer or a machine learning engineer. Also, without careful considerations, users could accidentally create a cluster which are oversized and too expensive to run. And these cluster policies help us to avoid these common issues. Administrators can create cluster policies with restrictions and assign them to the users or groups. In this example, we haven't selected a cluster policy and it is left as unrestricted. As you can see here, when a cluster policy is selected, the configuration becomes much more simplified. So in this example, a personal computer cluster policy has took up the option of multi-node, and the user can only create a single node cluster. Also, it defaulted the runtime version to machine learning runtime, limited the node types, and also auto termination set to 20 minutes. So we can assign this to machine learning engineers, and they will be able to create only these kind of small type of clusters. In summary, the cluster policy simplifies the user interface, thus enabling standard users to create the clusters, and it takes away the need for administrators to be involved in every decision. And and most importantly, it achieves the cost control by limiting the maximum size of the clusters. But please note that this is only available on premium tier, and hope now you got a good understanding about the configurations you can specify for the cluster.